So this is our third video in the organic chapter. We did properties of organic substances. That was the first one. The second one was hydrocarbon series, alkanes, alkenes, alkynes. And this is on isomers. You've never heard of the word. This is crazy. It's like trying to put jigsaw puzzles together. So the first thing is the definition of isomers. So it's the same molecular formula, which means it's got to have the same number of C's, the same number of H's, the same number of O's or N's or whatever's in the organic substance. You got to have the same number. But you have to have a different structure, and it has to have a different name then. Okay, so this is a little crazy. It's going to take your whole weekend to do what I'm going to give you to do. Little bit difficult to understand. So it's got to have the same everything, but it's got to have a different structure. And if it has a different structure, then it's going to have a different name. Okay? All right, so watch. Let's first do this one. You know, we've done this a million times. This is methane tetrahedron, polar bonds, but non-polar due to symmetry, and it's the first member of the alkane series, okay? Can we make this a different structure? Well, there's no possible way we can make this a different structure. So what I'm telling you is, alkanes in the alkane series, methane has no isomers because we can't make this any different than what it looks like now. Next, can we make this, which is ethane, a different structure? Well, let's see. Now, I'm not going to draw in the H's because of time, but you know they're there. So is there any way we can make this a different structure? Well, what if I did this? What if I took that carbon on the end, took that off, and put it below it? Did that change the structure? No, it's still two carbons in a row. So all I did was I took the ethane like this and I turned it this way. So ethane, you can't make any different structure because all we did is we went like this and then we went like this. So ethane has no isomers. All right, let's see if propane has any isomers. So there's three. So when you make an isomer with a hydrocarbon, always rip one off the end and put it somewhere. And the rule is, if you take a CH3 off the end, you can't put it on the ends. You can't put it on the ends. It's got to be somewhere in the middle. So watch. If I take that CH3, which is not called methane, remember, CH4 is methane. When I'm ripping off the N carbon with the three hydrogens on it, that's called a methyl group. So if I rip off that methyl group right there, and I put it here, I just bent it. It's still three carbons in a row. Remember my rule now, and you're going to have to remember this for the whole weekend that you're going to have to do the stuff for. If you rip a CH3 off the end of a carbon chain, you can't put it so it's on one of the ends because it's the same thing. So this is 1 carbon, 2 carbons, 3 carbons, watch. 1 carbon, 2 carbons, and 3 carbons. 1, 2, 3, they're all linked together, so all I did is bent the carbon chain. It's the same. There are no isomers for propane. None. So let's see about butane. Butane is this one, and remember they can be bent, twisted, whatever you want, but butane has 4 carbons in a row. Remember, it's an ANE, alkane, all single bonds between the carbons. So, there is butane. Now, what you're going to do for homework is, I'm going to give you some of these, and you're going to try to make an isomer out of it. So here's butane, and the formula for butane, I got 4 carbons, C4H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C4H10. So if I have to make an isomer, it's got to have the same molecular formula. In other words, it's got to have same 4 carbons and 10 hydrogens. Now, what you're going to start learning how to do is, if you're going to make an isomer from a hydrocarbon chain, rip the end one off and try to put it somewhere. Remember, you can't put it on the ends, but you can put it in the middle. So, there's my 4 carbon chain. I am going to rip that off, the CH3 there. Now watch. I'm going to rip this off. And remember, I can't put that CH3 here or here because it's at the end, and it would just be part of the longest carbon chain. So wait a minute, I can put that CH3 I ripped off from right there in the middle. If I put it in the middle, what's my longest carbon chain? 1, 2, 3. Before, my longest carbon chain was this. Was 4 in a row. Now it's 3. This is an isomer. So your first isomer in the alkane series is butane. But now how do you name it? Watch. I call it the tree trunk method. Circle the longest unbroken carbon chain. So, the longest unbroken carbon chain is 3, right there. That is the tree trunk. Name it. 3 carbons across, 3, the prefix is prop. So the prefix for that is propane. So the carbon trunk is propane, but what's that thing dangling down from the tree trunk? It's a branch. And how many carbons are in that branch? Just 1. That's CH3. And remember, I said CH3 is methyl. CH3 is a methyl. Well, we took a CH3 off the end, we took that one off the end and put it in the middle. So this is a methyl. So the name of this thing, and you have to tell me what carbon it comes off of. Well, here's carbon number 1, carbon number 2, and carbon number 3. So the name of this first isomer in the alkane series, it's got a propane trunk, and this little branch dangling off is a methyl, and that methyl comes off the second carbon. So this is called 2-methyl propane. That is your first isomer, 2-methyl propane. Now let's see if we can build any more from butane. So watch. Now we have this. If they're all in a row and there's no branches or anything like that, that's butane, but it's called N-butane. Normal. That's normal butane. So we're going to put this down. And N-butane, the molecular formula is C4H10. Now, the isomer, remember we removed that last CH3 and we put it in the middle. So it looked like this. Right? You can't put the CH3, this one, you can't put it on either end because that's just part of the longest carbon chain. Now, circle the longest carbon chain now, and we did that before. This is the trunk. And that's the propane trunk. And we have one branch coming off, and that comes off of the second carbon. So this is called 2-methylpropane. So now, for butane, we have normal butane that goes across. We ripped one off the trunk and put it in the middle, and now that's called 2-methylpropane. So my next question is, what if we rip off 2 carbons? Can we put them somewhere? Well, let's see if we can. Remember, it looked like this. I'm not going to draw the H's. So we're going to rip off 2 carbons. So we have this. And we have 2 carbons to play with. But the problem is, whichever carbon we put them on, it's going to be part of the longest carbon chain because they're going to go on the end. So if we put 1 carbon here and 1 carbon here, watch. Circle the longest carbon chain. 1, 2, 3, 4. Remember, it can be bent. You can't put the methyl groups, once you take them off the normal hydrocarbon, you can't put them on the ends. If you put them on the ends, that's just part of the longest carbon chain. All right? We're going to do some more until you understand what's going on, because these can be very tricky. So now we know this. There are no isomers of methane, because you can't change the shape. There are no isomers of ethane, because you can't do anything with 2 carbons. There are no isomers for propane, because if you take one off the end, there's no place to put it but the end. But you found 1 isomer for butane. All right? Because we took a methyl off the end and put it in the middle. Now, we're going to try to find out how many isomers there are for pentane. Remember, pent means 5 carbons. Ane means they're all single bonded. So we're going to put down this first. So they're all in a row. Now we're going to put the hydrogens. And don't forget, if they're all in a row, now don't forget, this chain can bend. I mean, that can be like this. It can look like that. It can be bent. It's like a chain link fence with the links being carbon. You can bend them as long as they're all in a row. Okay? So we have 1, 2, 3, 4, 5 in a row. The way you can figure out if they're all in a row is just like that. So these are 5 continuous carbons. So now, if they're all in a row like that, that's called normal. So this is N pentane. And don't forget, count them 1, 2, 3, 4, 5. C5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. Whatever isomer you build of pentane, got to have 5 carbons and 12 hydrogens. So the easiest way, the way I want you to build isomers, is rip one off the end. Rip a CH3 off the end. Remember, it's called a methyl group. and then put it somewhere, but it can't be put on the ends. So we're going to rip one off and go down to a butane trunk. So taking that one off the end, we go like this, 1, 2, 3, 4. We go down to a butane trunk. We have a methyl group right in my hand. Let's go like this. These are hydrogens. Now, where can you put this CH3? Well, we know we can't put it here, and we can't put it here, because that will become the part of the longest carbon chain. But we can put it in the middle. So we have two choices. Let's put it right here. Now, count the longest carbon chain is 4. So this is the trunk. And the trunk has 4 carbons in it, so it will be considered butane. Now, my next question is, one CH3 is called a methyl group, but you just can't say methylbutane. If somebody's drawing it, you got to tell me where the butane comes off. So, you number it. This is closest to this end. So we number it like this. 1, 2, 3, 4. So this would be the second carbon a methyl group comes off of. So this would be 2-methylbutane. 2-methylbutane. Now watch, this is a trick. People always go, hey, wait, we can take that and put it over here. But you can't, because watch. If I put this methyl group over here on this one, that is not 3-methylbutane, because since that branch is closest to this end, you got to count that way. Everybody got it? Wherever the branch is closest to, you got to number it that way. So if this branch is over here, we got to number these carbons. This is number 1, number 2, number 3, and number 4. So this would also be 2-methylbutane. Everybody got it? Because look it, if I took this and ripped it off the board and showed it to you, the methyl would be over here. So what you have to do is find out where the methyl group is, what end the methyl group is closest to, and you number the carbon that way. It gets a little confusing. All right, so now we know we have 2-methylbutane. If we put that here, that's also 2-methylbutane. So let me redo this. Okay, now let's go back and do this again. I took a methyl group off the end of the pentane. Now I have a butane trunk, which is right here. So the trunk's name is butane. And that methyl group comes off the second carbon. 2-methylbutane. And don't forget, if I put that over here, that's not 3-methylbutane, because that is closest to this end. You got to number it that way. So now my next question is this: can I take another methyl off? So I would have a propane trunk. This gets kind of crazy, so watch. You take the first methyl off, you put it wherever you can, and then once you've exhausted the possibilities of a butane trunk, we go down to a propane trunk. But remember, you got to have 5 carbons and 12 hydrogens. So let's see. If I go down to this, 1, 2, 3. If I go down to a propane trunk, if I go down to a propane trunk, I have taken 2 off the end. So remember, if I have 2 methyls, you can't put them on the ends. So is there any place I could put those 2 methyls that wouldn't be on the ends? Yes, watch. I can put one of the methyls here and one of the methyls below there. Like that. That doesn't look like anything we've drawn before. So now the longest carbon chain is this. So that's why it's propane. But now I have 2 methyl groups. Now watch, this is where it gets a little crazy. Both of these methyl groups come off the second carbon, right here. So what you have to do to name this one is 2, 2. So I have 2, 2, and they're both methyls, so it's this. I know it's confusing. 2, 2, dimethyl. Well, why is it 2, 2, dimethyl? Well, one methyl comes off the top, one methyl comes off the bottom. So that's 2, 2, and the di means I got 2 methyls. So 2, 2, dimethyl propane. That's 2, 2, dimethyl propane. And that would be the second isomer of pentane. The second isomer of pentane is 2, 2, dimethyl propane. All right? Now, if I take a third methyl off, you can't put them because you'd be putting them somewhere on the ends. So, we know that pentane has 2 isomers. All right? Now, I'm going to show you one more because your homework for this is to build in class. We're going to do hexane. Your homework is to do heptane, all the isomers of heptane. So in class we're going to do the isomers of hexane, but I think we're going to try to do this right now. So we know pentane has 2 isomers, 2-methylbutane and 2,2-dimethylpropane. Those are the only 2 isomers that pentane has. Now we're going to do hexane. Now just watch, because it does get crazy. The first thing we got to do is first build normal hexane, which means there's 6 in a row. So that's normal hexane. And don't forget, what we're going to do next is you always rip off a CH3 from the end and put it somewhere. And you can't put them on the ends. So watch. If I rip off one of these, I'm down to a 1, 2, 3, 4, I'm down to a 5-carbon trunk, which is pentane. So I'm down to a pentane trunk. Now, where can I put that CH3? Where can I put that methyl? Well, I can't put it on the first carbon, and I can't put it on the fifth carbon. So I can put it on the second carbon. So now I have a pentane trunk with a methyl coming off the second carbon. So this would be called 2-methylpentane. Is there any other place I can put that methyl to make an isomer with a pentane trunk? Yeah. What if I put it right there? So let's do it. We have another, this is our second isomer with a pentane trunk. So what we're going to do is, we already have it off the second carbon, why don't we put the methyl off the third? Like that. So here's our 5-carbon trunk, and now this is not called 2-methylpentane, it's called 3-methylpentane. Now watch, because this is a mistake you're going to be making. What if I put that methyl group on this carbon? Remember, now this methyl group is closest to this end, so I got to number it that way. Everybody got it? So there's no such thing as 4-methylpentane, because watch what happens. If I put that there, you number it that way. So 4-methylpentane would really turn out to be 2-methylpentane. So here's my rule. When you're making isomers and you're putting that methyl group somewhere, once you cross the midpoint of the trunk, you got to number it from the other way. So you can't cross the midpoint. If you cross the midpoint, like I said, you got to number it backwards. Has everybody got that? Okay, so now look at. So what we have is this. With a 5-carbon trunk, we have 2-methylpentane, we have 3-methylpentane, and that's all for that trunk. We can't cross the midpoint. Now, what we can do though is, we already took one off the 6 carbons in a row. Let's take 2 off the 6 carbons in a row. So in other words, we have 2 isomers with a pentane trunk. Let's go down to a butane trunk. All right, but remember, we still have to have this. We still have to have 6 carbons and 14 hydrogens. Because remember, isomer, same amount of carbons, hydrogens, oxygens, whatever, but a different structure, different name. So we are going to take 2 methyl groups off this guy and go down to a butane trunk. So we have a butane trunk, and now we have 2 methyl groups to play around with. Remember, you can't put them on the ends, so where can you put 2 methyl groups? Try to put them in the middle. You can put 1 methyl group here and 1 methyl group here. So here's your longest carbon chain, which is a butane trunk, and we have 2 methyl groups. And so you got to number them, and whichever way you number them, it's going to be the same. Look at 1, 2, 3, 4, or 1, 2, 3, 4. So now, if you were telling somebody how to build this thing on the board, you know that it's a 4-carbon trunk, so the end name would be butane. You have 2 methyl groups. So you know, if you have two methyl groups, that's going to be a dimethyl. Now you just got to tell the person where they come off. 2, 3. So the name of this isomer is 2, 3, 2,3-dimethylbutane. That's the name of it. Now, is there any other place we can put those two methyl groups? Yep. Remember, we can't put them on the ends, but we can do something else with the butane trunk. So watch. So we're going to go butane trunk again. Now, we can put these two methyl groups somewhere else. And the only other place we can put them is one on top and one on the bottom. So watch. We can put a methyl group right here, and we can put a methyl group down below it. So watch what we have. We have the 4-carbon trunk, which is butane. Now, if you were telling somebody how to build this, you just couldn't say it's dimethyl butane. You got to tell them where the methyls come off. And look at 1, 2, 3, 4. So both of these methyls come off the 2-carbon. So the name of this is 2,2-dimethyl. Look at 2,2-dimethylbutane. All right. Now somebody is going to go, well, what can we do this? Can we take those two and put them on this one? You could, but these two would be closest to that end, so you got to number it that way. Everybody got that? Now watch what happens. I'm going to do it right now. So if we wanted to put the two methyls here, that is not 3,3-dimethylbutane because you've crossed the midpoint. Once you cross the midpoint, you got to number it that way. Okay, so this whole thing would be 2,2-dimethylbutane, which we already have. All right, these get really tricky, and hopefully you'll be able to understand this more when you see this video, but we're really going to go over these for Friday. Okay? So, that's part of what we're going to do. And don't forget, your homework for this video is going to be try to get 8 isomers for heptane. And you're going to put them on this page. And what you're going to do is you're going to write it down, and then you're going to name it. Write down the structure, name it. You got 8 of them to do. All right.